So now moving more into the soil science aspect, that gets us through I need to kind of have a concept of those. Almost if you didn't remember any of that, you'd still be able to make good soil. So it's important from a soil science standpoint, but let's move into more of how does it look like more practically. So scientists describe soil horizons. So if I, for instance, dug a hole here, and then we all got down inside, so I dug a hole 2 meters deep, I'd see the first layer, right, is the grasses. Assume there was grass growing. And then the grass is growing on the first horizon, which you call the organic layer. That's things that are breaking down. Then we have topsoil. That's living soil. Topsoil needs air and water. So at the level where the air and or water no longer can penetrate, the soil changes to subsoil. What subsoil is basically non-living. It's compressed. There's not enough air. Most of the time it's an air issue. Why is there an air issue? Because the weight of the topsoil it weighs so much that it smushes the subsoil. There's no air, and then the microorganisms cannot live. Then we have the parent material. So at some point, every site being different, how deep is it for your soil level to get to rock, like the parent rock? This is where in your site, the minerals on your site come from, the parent rock. And then finally below that would be considered bedrock, okay? So here's a picture. We can see what that may look like. So that creates what is described as a soil ecosystem, or the soil food web, as popularized with Elaine Ingram. So all of the living things in the soil, plus essential materials that these organisms use to survive, form the soil ecosystem. So we include them, their home, and their food. So if you remove the food, they die. You take away their home, there's no place to live, or there's no life. It doesn't matter if you have food source or not, or home. So we need all of them, and this forms an ecosystem. And then we can start to look at them in what's called a trophic pyramid. So a pyramid of how they relate to each other. So soils are rich in ecosystems. They're composed of both living and non-living matter with a multitude of interactions. So then we can start to break these into basically periodic table interactions, the nitrogen cycle, right? The oxygen cycle, the phosphorus cycle. So we can see how the minerals are cycled through from the decaying matter through the animals that eat it into the new plants eaten by the larger animals and then defecated back. So this mineral cycles through continuously, and that makes life on Earth currently able to succeed. So the soil ecosystem basically has some very critical cycles that we're going to focus on, but there's what they call macronutrients we're going to see, and micronutrients. The macronutrients are the most prevalent, and the micronutrients are also necessary, but you don't see them as much. So the soil plays an important role in all of our natural ecological cycles, the carbon cycle, so we can talk about that from a global warming standpoint, the nitrogen cycle, oxygen, water, and the total, what we're going to describe as a nutrient cycle. So these bigger ones, and then nutrients. So towards the end, I hope that we're going to get through soil science and move into more of almost nutrition, okay? Soil is the basis for nutrition. The nutrition that people talk about, if they speak correctly, is describing minerals. Minerals is what makes you healthy. And if you eat food that is demineralized or does not have minerals in it, this is what creates disease. Our diseases being mostly tied to mineral deficiencies. We see that in plants, we see that in animals. And it's only recently that a sect of people have decided that humans are not animals. So if in every other animal on the planet it works this way, how does it work different for us? How did all of a sudden we stop becoming an animal when every other animal works that way? So this is how the minerals cycle, and if we can start to hone in on that, we can then make sure that those minerals are present in our garden, so that when our family eats our food, it's going to have the right mineral profile. So we can do tests to see if we have mineral deficiencies, and if we have mineral deficiencies, then the test helps us to add those minerals in so that we grow more nutritious foods. And you can go to Whole Foods, and there's nothing on the label that says the minerals, guys. Not a single company in the world that I know of will show you that. But there's a few people that are CSAs particularly, they're starting to print their mineral profiles, their soil tests on their websites. So each month they have what's called an integrated soil fertility management program. So they get a test of their nutrients because they're exporting their nutrients. Do you realize that when a farm sells you the product and you do not return your feces to that farm, those minerals don't come back. So if a farm continues to export minerals and it has no program to put the minerals back, how could the food over time stay as nutritious, right? And or even be nutritious? Because let's be clear here, NPK, it looks like a tomato, shiny like a tomato, smells like a tomato, but you don't know the micronutrients are there because the farm depleted them. So that's what the thing we want to focus on. What minerals do we have, and how do we, if we have a depletion of minerals, how do we change that? So the first one, the carbon cycle, the big cycle. Soil plays a critical role in the cycle of carbon, since the majority of carbon in the atmosphere comes from biological reactions within the soil. So more than like 80% of our biological reaction of carbon on our carbon scale is from soil interactions. So if we can increase that, we can sink more carbon, okay? So when we deplete ecosystems, when we create deserts, this desertification issue, that creates carbon releases. So what was living dies and is released back, and then it's not facilitated back. So expanding deserts, an expanding desert system is bad for our carbon balance, okay? A sink versus a release. We have the nitrogen cycle. It's within the nitrogen cycle that soil bacteria convert nitrogen into usable elements, okay? Called nitrogen fixation or fixing for plants, animals, and humans. So without nitrogen denitrification bacteria, those cycles don't happen, at which time the plants and animals living on those soils will become sick, okay? So we have veterinarians are very acute to when they go to, if it's more veterinarians and not people working for factory farming things, instead of giving them antibiotics, you can mostly solve all animal issues in your farm with the food source. So when you give them the correct food, they don't get sick, okay? And we're also probably a thing of that. So if you eat better foods, you're gonna get sick less than a person. And that's also tied to stress. So we have this balance between eating well, but if we still live stressful lifestyles, stress will trump no matter how well you eat. So if I'm stressed out all the time, just like animals, when animals are put under stress in these farming conditions, even if they have good food sources, they still become sick. Then they juice them up with the antibiotics, trying to overcome the stress of them being confined in the cages, for instance. Too many animals in too small a place equals stress. So the oxygen cycle. Oxygen is a unique and it often integrated into elements within other ecological cycles, such as water, H2O, carbon dioxide, CO2, iron oxides, and many others. So we need that. So the things that we see plants deriving soil to plant to animal cycles, oxygen is a key element. Photosynthesis is the key driver of oxygen. So cycles as plants take in carbon dioxide and they expel oxygen for animal and human use. Okay, so we need plants to create our oxygen cycle for the things that eat the plants. So there's a symbiosis relationship between what we see as soil to plant to animal and back, okay, through defecation. If a plant is not allowed to fulfill its life cycle, it oxidizes. So it dies. It doesn't allow the seeds to germinate typically correctly. They don't regrow, and the plant oxidizes and its biomass goes back to the atmosphere. So we want to not allow that to happen. So we have to understand how the plants react. So when we do our seed saving, we'll be able to identify how this plant reproduces. Some have very symbiosis relationships with animals, others not as much, and we can learn that. The water cycle. The water cycle is very dynamic, as water can change from vapor to liquid to snow to ice. So there's a lot of changing within the water cycle. Soil's role in this process is through infiltration, storage, and transpiration. So the tree, as we described, makes its own rainfall for transpiring. The tree or the plant is basically a pump. The roots are continuously pulling water up through the plant and pumping it out. It's what it uses for air conditioning. If a plant's internal cell temperature gets above like 60 to 70 degrees Celsius inside, it'll stop photosynthesis. This is a problem in the tropics. When you get like midday sun, it's so hot, the plant's not actually producing growth. It stopped photosynthesis. That's where you can see them wilting. They don't have enough water to offset the temperature. That's why the summers, like in England, the plant growth in a temperate summer is so high. What happens? You get longer days with cooler ambient temperature, so the plants get bigger. Think about the size of brassicas and these huge cabbages. Go to Norway and they can grow cabbage that's this tall. All right, how do they do that? Well, they have long light with low temperatures equals huge plants. That doesn't happen here. So in the tropics, yes, we can grow year round, but we can never get to that type of soft foliage. It's just not capable. So varying ways. So the nutrient cycle is the exchange of organic and inorganic, the minerals, back into the production of living matter. It decomposes matter into mineral nutrients. So that's what we're going to try to move forward to understand these mineral nutrients. What are the nutrients tied to the minerals, and how do we get them from the soil into our food, into us to be healthy?